All right. All right. So Kaylee and I are here. She agreed to record this for the class because there might be more of you having the exact same question she does. And so thank you, Kaylee, for that. You said 11B in section 8.3. Okay. So what was you were okay with A then, right?
Yeah, I was okay with the rest of them, but
So what
I think the square root is
kind of tripped you up?
confusing me. Yeah.
Okay. Well, do you mind if I ask, follow me through your thinking on A? What did you do with A?
Um, so for A,
Uh-huh.
I followed the little visual. It
Yep.
helped a lot. So for A, five x equals 5.
Okay.
So I input that into the little machine.
Hmm.
And I got um would it be f of 5 equals 5 minus 1?
That's correct. Yeah, you could write it that way. F
Okay.
of 5 equals 5 minus 1.
Or you could just keep it 5x, right? Or
Um, I mean, X does equal 5. So wherever we see an X, that would be 5.
okay.
So, but the notation you have is perfect for what we have to this point. Okay. Did you do
Okay.
anything else with it?
Um, yeah, so then I did 5 minus 1, which
Uh-huh.
equals 4.
Okay. So I'm going to put that in blue because I want you to remember that it was 5 minus 1. Now you simplified it to be the number
Yeah.
4, but that is still 5 minus 1. Okay. Then what did you do next?
Maybe I'm getting confused now. Because after that, then I input,
Hmm.
oh, but 5 is x. So, because then after that, I did 4
Hmm.
times 7, and then I
Okay.
got 28.
Got it. Because you did 7 times X. Now, X, this is where it gets a little confusing in math.
Hmm.
X is the input into a function. Once we put it into a function, what comes out is truly f of x. That's the output from the function. You found it to be 4 or 5 minus 1. And then once we plug that into this new one, we can think of the new input here as being like a new x. And then
Okay.
there's that. So what you did, there's nothing wrong with it. You said at the end 7 times 4, and you got 28 as your final output, right?
Yeah.
So we would write this as either this is the fancy way of writing it. You could also write it where you say, I found f of 5, and then I put that as the input into G, but I got 28.
Okay.
But now, if you don't mind, I'd like to go back just one step because I think this will help you with part B. Okay. You said it was 4. Could you have done the same thing if you left it as 5 minus 1?
Yeah.
What would you do with that 5 minus 1 down here?
You do 7 times and then in parentheses 5 minus 1.
Okay. Now, if we wanted to multiply this out, we could. And
Hmm.
this is not surprising, but you get 35 minus 7, right? The distributive. And guess what 35 minus 7 is?
28. Yeah.
Yeah. Okay. But I want you to see you didn't have to simplify. You could have kept going. So now, if you don't mind, can we walk through what would you do if it was the square root of 3?
Okay.
What are you going to do?
Um, so you would input that. So f square root of 3
Uh-huh.
equals square root of 3 minus 1.
Okay. Sure. Okay. And now that becomes your output, but it also becomes your next input. So what would you
Input.
do to finish this one off?
You could do 7
Mhm.
times and then in parentheses square root of 3 minus 1.
Okay.
So that's all you have to do?
If you want, you could distribute this.
Yeah.
You don't have to. You know it's going to be the same
Okay.
result. So you could have written it this way if you wanted to, where you distribute the 7 and multiply it by each piece. Sure,
Hmm.
you could do that.
Okay.
Or you could leave it like it is here. And I think sometimes students get a little concerned or confused. They're like, what am I supposed to do with the square root of 3? Nothing. I mean, it says what it is. It's 7 times the square root of 3 minus 7. If anyone wants to grab a calculator, they could go find an approximation for this if they wanted to,
Hmm.
out to 10 decimal places or 5 or whatever they want. But you've given them the exact value they should get at the end of the day. And you
Okay.
said you were okay with D, right?
Yeah.
What did you get for D, if you don't mind me asking?
Um, for D, I did the exact same thing we just did.
Uh-huh.
So I input A as
Yeah,
X, and then I ended up with 7A minus 7 because I
interesting.
did distribute.
Interesting. So what I want to point out is if, and this tends to be most of the time people see part D and they're like, that's the worst one. Let me do all the other ones with numbers. But if you had started with D as your first one, I want you to understand you could have gone back and just plugged a 5 in right here and been done with the whole thing.
Oh,
Or you could have plugged a 10 in where you see A and been done with the
yeah.
whole thing. So that's the goal of this is to kind of get you to see these bigger pieces. And the same thing is true here. If you had the square root of 3, right? I just
Hmm.
plug it in where I see A, and you end up with this thing. And you're like, okay, that's it. I'm done.
Okay, that makes a lot of sense.
Cool.
Yeah, I think I just got intimidated by the
Yeah,
square root.
I know. I thought like if I was doing this, maybe I would have pushed A up a little bit, but most people just skip right over the square root of 3. They're like, oh, I don't know what to do with that. No, it's okay. Just no matter what it is, it could be a cloud. What would I do with a cloud?
Hmm.
Well, I get cloud minus 1 and then I multiply by 7. And okay, doesn't matter. So,
Okay.
okay.
Yeah.
You feel more comfortable with that, it looks like.
Yes, I do.
Okay. Yeah.
Um, and then I think I was just confused with the directions for number 12.
Number 12. Oh, okay. So it links back to what we just did.
Yeah.
Oh, hold on. What was the one you found for D? Let's write it up here again. Your
Um,
final output.
7A minus 7.
Okay, so that is the final output, right?
Hmm.
And if you read this carefully, it says we want the final output to do what?
Equal twice the input.
Okay, what was your input?
Um, for which one?
Like this is in problem 11. When you got this as your final output, what was your actual input?
A.
A. And what do
Hmm.
we want it to equal?
We want it to equal twice the input.
How would I write that?
Um, would that be times 2 or squared or something along those
But what is
lines?
times 2?
Um, the input?
And what was the input?
A.
So,
So
best guess?
2A?
There it is.
Oh, okay.
And then what you're going to solve for, notice the thing you don't know yet is A, right?
Hmm.
But that is your input. So you're about to find what input is going to make this actually work. Maybe there's 2 of them, maybe there's 5, maybe there's only 1. Or maybe there's none. Maybe none of them will ever work. But that's what you're doing.
Okay, that makes a lot more sense.
Mhm.
Um, and I know for 14, I watched the video, so I got C.
Okay.
but I think all the parentheses are really throwing me off. So I feel like if we do either like A or B, one of them, because I think the parentheses are just throwing me off.
All right. Well,
Because C made a little bit of sense, but
let's just we'll just color code it then. Okay. So let's start. Which one you want to start with? And do A or B? Doesn't matter.
B.
I knew you'd pick that one. Okay.
I
So let's see.
know.
Okay, so I'm gonna do this, and I'm gonna try to color code it.
Okay.
Okay. I'm gonna do my best. If I might mess up, but I'm gonna do my best.
Okay.
I'm not as quick with these tools as some other people are, but okay, so here we go. So now, could you find the blue part, which is f of the square root of 2? What would you write?
That would be um f square root of 2
Hmm.
equals the opposite
Uh-huh.
of the square root of 2 plus b.
Okay. Right? Because you said this piece right here gives me that. So all that we're doing now is we're going to take that as the
Mhm.
next input. That's all it is.
Okay.
So now where you used to see X, you're going to put this whole thing inside. Okay.
Okay.
Okay. So I'm just going to sit here, but you tell me what to write.
Okay. So that would be f, then in
Hmm.
parentheses,
Big nasty
um,
thing.
that, the opposite of square root of 2 plus b.
Okay. Yep.
And then you said it equal. Oh, wait,
2.
it's already equal to.
Hmm.
Um, the opposite of the square root of 2 plus b.
Okay. So hold on. Now I'm going to change colors. You
Oh.
can see it. This becomes the input. So this is the
Mm-hmm.
opposite of the square root of 2 plus b. There's that piece. Yep. Hmm.
Mm-hmm.
That's just the X though. So don't forget the rest of it.
Plus b.
Because the formula was
That's
the
right.
opposite
Yeah.
of the thing plus b.
Okay.
So temporarily, this chunk is acting like X.
X.
And so all I did is treat this thing right here. I said, well, that's like my X. So wherever I see an X, I replace it, but everything else has to stay. The opposite symbol and the plus B, all of those have to stay.
Okay.
Now we got a little simplifying though. Now we got a little work to do. Like we're not done, right?
Yeah.
Okay, so are you comfortable distributing this negative symbol? Maybe I'll use green just so I don't mix it up. Are you comfortable doing something like this?
Yeah.
Okay, let's do
So
that first.
that would give us, so would it then be a negative or would
No,
it still,
let's leave the big red ones alone and just simplify the blue.
yeah,
Okay.
would, so it would be negative square root of 2
Uh-huh.
minus b
There we go.
and then plus b.
Mhm. Any simplifying you could do here.
Yeah, the
Like what?
b's cancel each other out.
You gotta love that, right? Take away B,
Hmm.
but then add it back. Done. So let's simplify this a little bit. That symbol's still out in front. I still have my red parentheses, but the only thing that's left is this.
Hmm.
Okay.
So that means it's going to be the opposite of negative 2 square root of 2,
Mhm.
which would be positive square root of 2.
Done.
Okay, that makes sense.
So again, the tough thing I think for students as they look at this is you kind of get in the weeds when you're doing a specific value. And I know
Yeah.
it seems kind of strange, but if I could convince students to say, what if I just called it f of cloud? Then I'd have minus cloud plus b, right?
Hmm.
And if I plug that in and tried it, what is f of that thing, right? Well, that would be minus this thing plus b, but that thing is the chunk that I'd put in right here. So I'd have minus the same thing you had a second ago. You just had the square root in there, right?
Hmm.
And then I'd ask you to simplify and you'd get the same thing. You'd have a little this thing minus b, right? But then you'd have a plus b at the end from the other one. You'd have an opposite symbol out here. Are you okay with what I've done so far? So I'm not trying to
Yeah.
lose you. Then you'd see exactly the thing that you saw and you'd say, well, these are gone. And then to me, the beauty of this is what's left is just that chunk. And when I take the opposite of the opposite, what do we get?
Positive. Yeah.
So what this says is if you start by plugging in the cloud and you do a whole bunch of stuff, guess what you get at the end?
The cloud.
Yeah. So if I started with square root of 2, guess what I'm going to end with?
Square root of 2.
Because that's the cloud. And
Okay.
if I started with 0, right? What would I get at the end?
0.
Yeah. And what if like someone's like, oh yeah, I'm really going to screw you up now. What is f of square root of 3 minus 5 square root of 7? And you're like, square root of 3 minus 5 square root of 7. They're like, God, you're good. You're really good. So they can make it so it's complicated. It actually becomes easier if you solve the general case. And then you're like, then I just plug in what it is, just like we did
Hmm.
back in number 12, where we found 7a minus 7. We're like, oh, actually, that's easier. Let me just do it that way. I can plug in any number.
Okay. That makes. I think I'm what when do we use like functions? Um like what are they used for typically?
Like in the classes that you have right now, or in the future elementary school. Like,
In the future elementary school.
so the function idea is the culmination of many ideas you've done to this point. So it's
Hmm.
formalizing the idea that I take an input value and I can get an output value. So if you remember back in 105, we had like a sequence, right? And it looked a little something like this, right? And
Hmm.
you'd simplify that sequence, and maybe your sequence turned out to be 3n minus 2 or whatever it was. We didn't call it that back then, but this is really a function. You put in the number n, you get out anything you want.
Okay.
So we don't start at the K to 5 level saying this is a function, but we build the foundation for it. Now, later on in math, the basis of a foundation is what we're kind of seeing here is, hey, oh my gosh, if I use function notation, I can get to the end of things a whole lot quicker than if I don't. I might be able to, like we just did a moment ago, like the output was just the cloud. Oh, that's a heck
Hmm.
of a lot easier than trying to go through it step by step with these numbers that could look very, very challenging. So we use them as a way of not just graphing, so I can visualize a function, but we also then, as we build on them down the road, again, this is beyond what you're saying you want to teach right now. Right now, you said something like K to 8, maybe. But if you get up higher than that, then we would actually say, well, how can I go backwards? Can I take the inverse? Can I undo this function? And so this gives us the idea that we do things and we undo them, that we go forward and we go backwards. And again, you've built that baseline, hopefully, at the elementary school level by saying when I add something to a number, I could undo that by subtracting. When I multiply by
Okay.
some number, I could undo it by dividing. Those are operations, and a function allows you to generalize that to other things. So it's kind of like we're building up to this level through the K through 8 grades. And again, I mean, this is also the college level class. So it's trying to say, well, where else would I do something like this? And I'm going to tell you, you will see things like function boxes because one, it's kind of fun for kids. Oh, I put this in and I
Yeah.
do something to it, but they won't use that function notation. They will simply, here's what they'll say instead. So this box right here that says f of x equals x minus 1, they would say this. Is it the same concept?
Yeah.
Yeah, but one of them is a little bit more formalized that will allow you to go further. At the K to 3 level, saying subtract 1 is probably just fine. They get the idea, and you say subtract 1, and then what? And this one would just say multiply by 7. And again, that would be the command. But you as a teacher would say, actually, there is a basis behind this that allows us to take these concepts and put them together, functions together, composition of functions. Um, I mean, over here, this is an area function or a perimeter function. And really what
Hmm.
you're doing, whenever you have I mean, you grew up with formulas, I know you did. And so all those formulas you had, those formulas are almost exclusively functions. The area formula for a rectangle was length times width. Awesome. Just understand that is a function where I put in a length and a width and I get out an area. That's what we're really doing. The
Okay.
properties of functions can then apply. Each input gives me exactly one output. That's what we want. We actually were doing that before in the other math class. Sometimes you saw the word unique. You have to have one and only one answer. And so again, they were trying to get to the idea of functions, but they didn't have the language yet, and they didn't have the formalization. So we did what we could to make sure students were building up to where we could then use this cool tool.
Okay. That makes sense.
It's a tough thing when
Yeah.
you are teaching at this level. It's tempting to say, but I'm only teaching this, so I don't need to know that other component. But what I'm hoping you see coming out of this class is, holy crap, I'm laying the foundation for a
Hmm.
lot of these pieces. So I really need to understand at least where my piece fits in. So I'm really glad you asked that question.
Yeah. Because that's the one thing is like I really want to understand everything because I want to be able to teach them the more simple stuff in a way that
Yeah.
will set them up for success in the future.
Yeah. And that's the thing with like when I showed Desmos, and again, I'm not sure how much you were in class when I was doing Desmos, but in Desmos, you can actually write in a function like the one that
Hmm.
you had a second ago, 7x minus 7, right?
Yeah.
And then I can visualize it. I can say, oh, so every time I increase my input by 1, right?
Hmm.
So this is the 2, 7. If I go over to 3, the number 3 is my input, I'm going to go up by another 7. And let me go down here. Sorry, I went a little too quick. Come on, 3. Come on, right on the nose. There we go. Look, at now it's 314. And I can tell it has to go up by 7 because that turns out to be the slope. I didn't call it slope when we did arithmetic sequences. We called it the common difference. But that common difference is how much I go up each time I go over 1 unit. That's exactly the slope of a line. And if I wanted to, like you said, you had the function and you said, what if I put 5 in? Okay, you got 28 out. Well, I can write f of 5 and I can show you 28 comes out. I can even graph that point on here as 5, oops, 5 comma 28. And you can see it's right on the line. It is a
Hmm.
solution. Boom, there it is. And if I want to find the next one, I would go up 1 and in X and up 7 in Y. So if I check that, I could say, well, wait a minute, what is 6 comma, actually, let me do this. Let me do X equals 6. So I can do a line of X equals 6, and you can actually see where it intersects. Oh, when X is
Oh,
6, it actually hits 35 right on the nose. And you're like, oh yeah, that's right. And then you
that's
could,
cool.
yeah, and you can actually choose, like for X, you could have X be a slider where you can just slide the line and see where it hits. I know,
That's
I think kids
cool.
are going to really love this. And it's way better than what I had growing up. So if I
Yeah,
say X is 2, well, then I just click and they'll show me and they'll say, oh, 2, 7. And you're like, aha, got it. Thank you, wonderful line. Anyway, that's the idea.
that's
So.
cool. I didn't know you could do that on Desmos.
Yeah, not only that, you could create a point. Well, okay, this is Scott being cheesy, but you can create a point that is X, and then you say f of X is your output. And so if I say f of A, I can add a slider for A, and A then moves, and it moves the point on the line. Because my input is A, and the output is f
Yeah,
of A. So anytime I want, there it is. And if I want, I can label it. There you go. And you can just watch it move. So
that's so
again,
cool.
but it's just showing the same relationship that we
Yeah.
already had. It's not like it's showing anything different, but this one's much more visual. And for some students, I think they really like the idea that, oh, I'm in charge of that.
Hmm.
Yeah. And yeah, you can come over here and say, okay, forget the y-axis is not going up quick enough. Maybe I want it to go up by what is that, by tens right now? I want it to go up by hundreds. Okay. Right. And I want this to go up to like 500. Okay. So now it doesn't look quite the same because now I'm going up by hundreds on this one, but I'm only going over by tens. But again, it's good for students to see that. And so as you move this point along, you could see that if I go over 10, I'm up 63. And again, that matches with our function. So a lot of cool things that you can do with technology now that I don't, when I was in school, elementary school, growing up, we didn't have anything like this.
Yeah.
So now students have the opportunity, if they were struggling to visualize something, you don't have to fight that anymore. You can actually say,
Hmm.
let's go visualize it. And I think you can
That's
even
cool.
just type the word table and it'll let you put the points in. So if we had the point 10, and then we had the point 27, then we had the point 314. These are the points that would actually been on the line, right? You can say 4
Hmm.
and 21. So you can actually, there they are. And I can zoom in. And so maybe this line is the problem. Turn the line off then. And there's a little, I gotta move my tools out of the way. But you just click on this and turn the line off. There's the dots. There, there's the pattern that we were making go up on 7, right? And I can just keep adding to it if I wanted to. 5 and was that 28? And there it is. And I think I can do, I think I can, I don't know. I'm going to try it. It usually doesn't like that. Let's see if I can do that. Can I? Will it let me? Oh, there we go. And it's up here. So then I can go back and turn the line on and say, there it is. Look, they all fall on a straight line. Everything's right there. I know. It's cool, but maybe
It
further than
is.
the question you asked. So I will get back
No, I
to
love it though. I didn't know you could do all that.
Oh, there's
So,
so much more. Like there's even a play button here. So when I hit the play button, like it'll actually just move for me back and forth between
that's
negative 10
cool.
and 10. And I can say, ooh, you're going too fast. Slow down a little bit so students can see what's going on. Okay, there you go. You can pause at any time. You can say how big of a step do you want to take? Where do you want it moving between? And so a lot of tools in here, but again, hopefully that's more of the methods class.
Hmm.
This is the content, and I do try to show how it can be used and how to connect it, but a concept gets put into practice through a lesson plan, and that will be in your methods class, which is usually the School of Education. They'll talk to you about how to scaffold things, how to build with what students know, and then how to use technology like this, I hope. So
Yeah.
a lot of students also just reach out to me later and they're like, hey, how could you do something cool like this? I'm like, all right, let's do it. I'll show you how to do it. So,
Yeah.
all
That's
right.
cool.
Yeah. Eh, Anything else in 8-3 before you continue your weekend? Maybe there was another
Um,
question.
yes, I'm trying to, because I feel like answering those questions is going to help me with a lot of other ones.
Okay.
So I'm good on those ones.
And I did a
Um,
follow-up video on number 20. I did a short one at first, and somebody said I'm still stuck on it. So I did one that's a little bit more expansive. I kind of went through it in much
okay.
more detail. So if that one is giving you, like, try it first. And then if you get stuck, then feel free to check out that video that is just very specific about that.
Okay. I think I just had a concept question
Oh, sure.
because I barely remember in class when we were doing the functions with the big circles and like the arrows.
Oh, the arrow
Or
diagrams. Yes.
yeah, yeah,
Yes.
yeah. So I know that
Things like this.
only like the 1A could go to 1B, but there can't be two A's going out to,
For
or I
for it
guess I
to be
was
a function.
confused.
Yeah, for it to be
Yeah.
a function. Yeah. So a function is each input maps to exactly one
Mhm.
output. So when you look at it, like the number 3, that's an input. So it has to map somewhere, and it has to map
Mhm.
to exactly 1. So it maps to a 7. The number 3 is okay. That doesn't mean the whole thing is a function yet, because it does say for each input. So you got to check them all.
Okay.
It just means that 3 didn't fail. Okay. Now, if you had down here, like 10 went to 21, but 10 also went to 11,
Then it wouldn't be a function.
then it's not a function.
Okay. But what if you had like 3 and 5 both go to the same one?
Oh, okay. Let's get some white space here. We'll draw our own. Then you can tell me the what ifs to your heart's desire. And that way it doesn't look like we're kind of just, it gets a little blurry otherwise. Okay. So over
Yeah.
here, you've got a few points over here, and honestly, it doesn't matter what they are. I'm not even gonna
Mhm.
put numbers on them, but this is like set A, and over here is set B. Okay, so tell me what you want.
A A is the domain, right? And then B is the codomain.
That's correct. Yeah.
Okay.
And
Um,
then the points that we hit, the pieces in B that get hit, that's called the range.
the
So the
range.
actual
Okay.
outputs. Yeah. Okay.
Okay. Because I
So
was
you,
reading the textbook and I
uh
was trying to, but I didn't, not that I remember, it didn't touch on this. So if, say, 2 points
okay.
in A, so like A and B
Okay.
both go to the same point
Oh, okay.
on
So something like
B.
this.
Yes.
Okay. And you're
They
asking,
both
is
go
there
to
a problem with that,
exactly
right?
one.
Yeah.
Yeah.
So is that a problem? Well, let's take a look. So remember the definition, this is what we always want to go back to, says
Hmm.
each input does what?
Has to equal exactly one
Has to
output.
map to exactly
Math.
one
Yeah.
output. Okay, so let's take a look. Let's take a look. Here's the input A. How many outputs does A map to?
One.
Okay, let's look at B. How many outputs does it map to?
One.
Let's look at C. C's having a serious problem because it's not mapping to anything.
Yeah.
So this would not be a function right now because of C.
Hmm.
No problems with the A and the B. What happened up here is fine.
Okay.
Everything's fine. As a matter of fact, this could occur,
Okay.
and every input does map to exactly one output. Now there is a little bit of a distinction. Let me go back. If you're okay with it, I'll show it to you on Desmos to kind of illustrate that, because
Yeah.
sometimes that can be helpful. So let me cut everything else out of here. Okay, so watch this. F of x equals 7. Okay. So if you put an input of 3, what's your output?
7.
Put an input of 5, what do you get?
7.
F of 17.
7.
Okay. It's like the most boring function ever. Right? It's like talking to a third grader, right? What
Yeah.
number is 7? How many brothers do you have? 7. You're like, okay. Are you just always going to answer 7? 7. So what that says though is when you look at it visually, this does not violate what a function is. Okay. Now I'm going to put something else up here. Okay. Take a look at this thing. Okay. That's a cool shape, right?
Yeah.
But what we're asking is it a function? So what we want to do is we want to look at, uh, oh, I got that in there. This equals b. Oh, I gotta be careful. Did I already define b? I don't think I did. It won't let me add a slider there. So what I really want to do is I want to do x equals, I'll say x equals 1. And I'm going to change the color on this just so we don't mix it up, okay? So take a look. Here's x equals 1. And when I click on the line, I want you to notice something. The input of 1 has 2 outputs.
Mhm.
So this beautiful picture right here, forget about the red line, just this beautiful picture right here, this beautiful, looks kind of like an ellipse. That's not a function.
Mhm.
Because when I plug the number 1 into it, it fails
Okay, because it has more than
because it has
just
more than
one.
one output. So what we do is we think about, if you want to think about each input, think about it being like a vertical line that slides across. And if it ever touches more than once, fail.
Okay.
But over here, if you take a look, if I say just x equals 3, well, it only touches once. That point, that indicate that is not an issue. But if I said x equals 2.8, oops, 0.8, oh, come on. Okay, 2.9, whatever I can get. Now I can see, oh, actually, that hits twice. Oh, then just that one thing, all it takes is one, and it fails being a function. The reason I bring it up is when you take a look back at your original line, if I took this vertical purple line and slid it left and right like I did before, is it ever going to touch 2 points on the red line?
No.
That tells you visually that this is a function because it
Okay.
never fails. Okay. The difference between that and the functions we've seen like this, where we kind of have a slanted piece because the numbers keep changing, they're not always the same. The difference is this function in red is called a one-to-one function, and that's beyond this class, but to help you, because I think that's where your issue is stuck, is each input goes to a different output. That's what we have
Okay.
here. It's
Yeah.
possible they could all go to the same output, but if they do go to different ones, then we have what's known as a one-to-one function. Each input goes to a unique output. That's a little bit different. It's a special case of a function. The other ones are still functions. This one is just a little bit different.
Okay. That makes more sense.
Mhm. So again, that's what you're really looking for, and that's why in some of these pictures, I think not that one because that one, all those worked out really nicely. But there were some images and they said, "Is this a function?" Right?
Mhm.
Like here, yeah, like this. So again, if I think of that kind of vertical line, just in your mind, you can draw it. You don't have to physically draw it. You can just kind of see it in your mind. But like say, okay, here's my vertical line, and then just drag that vertical line across the curve. Does it ever touch more than one point? And you can kind
Mhm.
of see it. Like if you just took your hand as that line and slid your hand across, you'd be like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, it only ever hits 1 point. That's a function. And you come down here and you do the same thing, right? How many times does it touch? 1, 1, 1, 1, 1, 1, 1, 1, 1. It gets boring saying one, but yeah, only hits one every time. Until what?
E.
Until down here, right? Because now it's 0, 0, 0, 0, 0, 0, 0, 1, 2. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2 for a long time. And that's where you'd say, I'm sorry. The second I say 2, it fails being a function. And again, sometimes
Okay.
that visual helps because you kind
Yeah.
of get that. Um, that visual is great for a graph. If you have those arrow diagrams, what you're looking for is single point, two things coming out of it, not a function.
Okay.
Mhm.
Okay. That because I think it was for number two. Um.
On the MC or on the,
No,
oh,
on 8.3 when it gives you two sets and then it gives you um.
oh, yeah. Is it a function or not, right?
Yeah.
Yeah,
I think I was getting it, and then when it, I think, which one was it?
probably B.
Um, I think for B, I said it's not a set because it can only be paired with one.
Oh, not
But
a
I think it
function.
was
Yeah.
C.
Okay.
I think it was
Yeah.
C because I saw B three times, and that's where I got confused.
Yeah. So that'd be the same thing as like, all of these go in the picture one. They all go over to that
Hmm.
point. Yeah, okay.
Yeah, I think that's where
Yeah,
I
it's
got
good.
confused.
I mean, yeah, it's good to say that. But again, you're looking for each input has to have exactly one output. Doesn't have to be different. They could all be the same, but it has to have exactly one. So you're looking for that counter example where, sorry, that is a fail because
Okay.
my input of 2 has two different outputs, and that just can't happen.
Hmm.
Yeah, if that happens in the real world, you get cranky. Because if you use the same amount of water that you did last month and your water bill goes up, you're like, no, no, you can't charge me more for the same amount, right? Because it should be a
Yeah.
function of what I'm doing. Yeah. So,
Okay. I feel like I'm good now.
all right.
That helped.
Solid.
Solid.
All righty. Sounds like a plan. I'll leave you to it then. If you have anything else, let me know.
Awesome. Thank you so much.
All right. Take care, Kitty. Bye bye.
You too. Bye.